Hello, my name is Tyler Wenndt. My partner is Drew Eagle, and today I'd like to present to you our solution for Columbus Software Systems. We began with two different sorting algorithms, one by Acme Corporation and one by Ajax Corporation, to be used as an SaaS, or Software as a Service Incorporation. CSS deals with different volumes of data every week, which on average is as follows: 10 million records for Monday, 1 million on Tuesday, 30 million on Wednesday, and the list goes on. Therefore, the question we sought to answer was ultimately, how should CSS implement their new sorting platform? However, in order to answer this, we had to collect some data. But firstly, what is software as a service? SaaS is when a third-party company or provider licenses software to different companies or consumers over the internet, often with some subscription rate or service fee. You may know examples such as Dropbox, Amazon Web Services, Outlook, or Google Drive. In order to evaluate which SaaS solution best fits CSS and their workload, we experimented by generating various arrays of sizes 1, 10, 100, 1000, 10,000, and 100,000. We then passed every array into each algorithm and recorded the number of instructions it took per algorithm to sort each array, as well as the time, in nanoseconds, taken on our independent system. These results have been documented as follows. To find the computational complexity of each, starting with Acme Corporation's sorting algorithm, we put it into a graph. We then compared this to similar complexities, such as big O of n to the power of 2 and big O of n times log 2 of n. To find the computational complexity of each, starting with Acme Corporation's sorting algorithm, we put it into a graph. We then compared this to similar complexities, such as n to the power of 2 and n times log 2 of n. Although Acme reported a complexity of big O of log 2 of n, we found that their complexity was actually more in the order of big O of n squared. For Ajax Corporation, we again plotted out the data recorded. We then compared it to similar complexities, such as n times log 2 of n and n. Ajax Corporation, unlike Acme, did not report the complexity of their sorting algorithm. However, according to our data, we found it in the order of big O of n times log 2 of n. Therefore, we can surmise that Ajax Corporation has the more efficient and probably quicker sorting algorithm when compared with Acme Corporation's, but we can validate this. From our earlier experiments where we recorded the times taken, we can already see that Ajax Corporation has a faster algorithm, at least on our independent system. This is especially true when compared to Acme Corporation's sorting algorithm when the input size is significantly large as shown here. We can try comparing this data to similar complexities, but at this scale it may be a tad difficult to accurately gauge the time complexity, especially when our data itself has some discrepancies as reflected with an input size of 1. When compared to other complexities, such as those we used before, it seems to match up well with a time complexity in the order of big O of n squared, the same as its computational complexity. Ajax Corporation, on the other hand, is more difficult to accurately determine the time complexity, even when compared to other complexities. Therefore, even though it may not exactly match up, we feel, at least from the data collected, that Ajax Corporation's sorting algorithm has a time complexity closer to big O of n times log 2 of n. Now, using the information provided to us by each corporation and the pricing models of their algorithms as shown, we can evaluate the most cost-effective solution for CSS to incorporate given the following daily volumes. We then calculated the cost of each different price option for both corporations as shown in this graph for Acme Corporation. However, we arrive at a dilemma. At these current price points, Acme Corp's second option is simply too expensive to accurately gauge the cost of the other two options, so we will modify the graph to remove it. Looking at the graph now, it is quite notable that in almost every instance for Acme Corporation's sorting algorithm, their first option is the most cost-effective. Following Ajax Corporation's pricing model instead, we find that their first price option is significantly expensive, while their second price option does not even seem to apply for CSS's current workload. Therefore, from the data collection from our calculations, it seems ultimately that Acme Corporation's first price option from their price model is the best. Based on the information now collected, and with further support by our experiments, we can now devise a solution that we believe will best fit CSS's new sorting platform. For every day except Tuesday, the use of Acme Corporation's sorting algorithm with the first pricing option is, by a significant margin, the most affordable and cost-effective. Furthermore, because the input size is quite small, the overall time taken should remain relatively low, with the remaining merging operations probably being the real, if any, time loss. For Monday, therefore, using Acme Corporation's sorting algorithm to sort on average 10 million records, we would split these into 100,000 different requests, with 100 records each time, and then merging each new sorted subarray with the final collection for a total cost of around $100,000 US. The estimated running time of the algorithm is big O of n squared, while the estimated running time of the merging operations is around big O of n, where n is the combined size of all arrays. For Tuesday, we will use Acme Corporation's sorting algorithm to sort, on average, 1 million records by doing one request with 1 million records for a total cost of around $13,000 US, with no merging required. The estimated running time of the algorithm then is just big O of n squared. Wednesday through the rest of the week follows the same pattern as Monday as shown here. Overall then, the total cost of these methods should be around $1,919,000 US. We believe this is the best solution for Columbus Software Systems as it was substantially less expensive. Although Aegis Corporation's sorting algorithm was more efficient and quite quicker than Acme Corporation's, the affordability of Acme Corp's was too significant. The potential time loss is therefore just not sufficient enough to warrant switching algorithms or using a combination of both, as the resulting price increase is too great. In conclusion, with the exception of Tuesday, we found that splitting the records into many smaller subarrays of 100 items each in order to fit Acme Corporation's first price model option would be the most efficient, while keeping overall costs relatively quite low. Thank you for your time.